All right, in this video, we're going to be working on graphing log functions. So let's go ahead and get started. Okay, so again, it goes on to say sketch the graph of the function using the appropriate x and y tables, identify asymptote and x-intercept, list all transformations, state the domain and range. Okay, so before I actually get into all of that, have your calculators ready. And something that I want to remind you of is when working with logs, everybody learned something called the change of base formula. So let's go ahead and write, you know what, I'm going to go ahead and give you guys a little bit of notes, okay? And let's go ahead and write, title it change of base formula. And the change of base formula is actually, you know, it's not difficult to use. So I'll give you 3 examples. I'll give you example A, B, and C. Okay, so let's say that I were to give you log, since we're using a 3 over here, let's go ahead and do log 3 of 4. Let's use log, I'll change it to 5 and 10. And then let's do log of, let's see, what would be a good number? Let's do log of 7 and 11. I don't know, just because it rhymes. Okay, so the change of base formula says the following. And by the way, change of base formula is very important because that's the way that you get to input your values into your calculator. If you don't do it this way, then of course, you're not going to be able to get the correct response. Okay, so here we go. So the change of base formula, and this is the part that's crucial. This is what I need you guys to remember, is that you guys are going to do log of the big number, log of this number, over the log of this number here, of 3. So by doing so, what you're actually doing is you're changing the little number that's supposed to go over here, this one subscript, to a 10. And so the calculator only understands base 10. All right. Now, depending on the calculator that you have, it might just do it for you. But for most calculators, they don't have that feature. So this is what we need to do. Okay. And so if I wanted to know how much this is, I would go to log of 4 divided by log of 3. And so notice how I'm coming up with a solid value over here. It's a number over a number. Okay? And so that's how much I would get. And if I wanted to figure this one out over here, this is going to be log 10. And it's going to be divided by a log of 5. And so that's how much we would get. And then let's go ahead and do one last one, log 11, and then divided by a log 7. So again, the calculator only understands base of 10. Okay, so let me close that parentheses. And so that's what we end up with. Okay, why did I bring this up? Well, see, one of the tasks that, that's on this list is that we need to come up with an X and Y table of values. And so, tell you guys what, let's go ahead and start with that. And just so you guys understand that this over here is really not that difficult. However, you do need a calculator for this. And I'm going to show you how to come up with it. Okay, now hopefully you guys found these 3 problems helpful. And tell you what, I don't like to start something and not finish it, so the way that we would write it out would be log 10 over log 5, and then of course, we inputted that into the calculator, and then log 11 over log 7. And again, the reason I'm bringing this up is because when it comes to this over here, as a matter of fact, I'm going to highlight it in green. That's what we're going to be doing. So, you know what? Let's go ahead and add a D example. And it's going to look like this. Log 3 x plus 4. And so the change of base formula for this is going to be log of x plus 4 all over log 3. And that's how this component over here is to be inputted into the calculator. All right? Okay, so let's go ahead and take some values. But I guess a problem that we would have when graphing a log would be, well, what would be the appropriate x and y values to substitute into here? Okay, so that's one of the reasons why we teach transformations. And as a matter of fact, let's list all the transformations. And the transformations are as follows. Let's go ahead and start with the 2. The 2 stands for a vertical stretch. Okay. Okay, so what this is saying is that whatever comes out of here is going to always be twice as much. It's a scale factor. That's what it is. Okay. Not only that, but we also have a horizontal shift, and the horizontal shift is going to be where x is equal to a -4. Where x equals to -4. Now, looking at the -5, that's the easy one, right? Because we don't need to solve for anything. That is the vertical shift. And the vertical shift is moving the graph 5 units 5 units down. Over here for the horizontal shift, let's write 4 units left. Okay, and this over here, you guys, it's actually very, very important. And let me explain to you guys why. Okay, and I apologize for giving you guys additional notes. I'm pretty sure that's not what you were expecting. But, when it comes to logs, we really need to understand it thoroughly. And I'm telling you, you do this on your final test, you're gonna achieve some success. Okay, so the first thing that I want you guys to recall is this. When it comes to a log function automatically comes with a built-in asymptote where x is equal to 0. X is equal to 0 produces this asymptote over here. And it's always there, okay? And the graph is always crossing at this point over here, 1, 0. It's always, always, always going to do that. All right, so with that being said, let's go ahead and apply the transformations. According to this, we need to shift the graph 4 units to the left and then 5 units down. I'm going to be using blue. Okay, so the first thing that we need to shift is always, always, always the asymptote. Asymptote is easy. You're just going to go 1, 2, 3, and 4. Negative 4, and the asymptote is going to be right there. All right? So I want you guys to also notice the following. The graph does not exist. Look at this graph. It doesn't exist on the other side of 0. So same thing over here. The graph is not going to exist on this side. So it wouldn't make any sense to choose points from this side. And you know, I'll show you guys later what happens. Okay, so now let's go ahead and move this point. So this point is going to go 1, 2, 3, 4, and then 5 units down. 1, 2, 3, 4, 5 units down. All right. And so the graph, of course, you know, there is a built-in factor of 2. And if you guys want to, yeah, I don't know, cheat the graph and use a factor of 2, I guess you guys can do like 2/1, and then from here treat it like a slope. You know, go 2 units up and then 1 to the right, 2 units up, and then try to formulate it. But because it's a dummy graph, let's not complicate things, and let's just leave it like this. Okay. Okay. So now what we want to do is we want to come up with our X and Y table of values. Okay. So once again, we need to come up with an appropriate X and Y table of values. It would not make any sense, you guys, any sense whatsoever, to input numbers to the left of -4. As a matter of fact, it wouldn't even make any sense to input numbers that are, you know, where X is equal to -4. All right, so now let's go ahead and do this over here. Let's understand how to input this into our calculator. First, turn it on, clear it. All right, so here we go. So a few things are happening here. The numbers that I'm going to be selecting for my X are going to be the following. I'm going to select -3, -2, -1, 0, and I'm going to go all the way up to 1. All right? I am going to go all the way up to 1. So what I'm going to do now is I am going to input -3 into here. Okay, so remember what I said earlier. We need to be able to use our change of base formula. So, tell you what, let me move my calculator out of the way. If I input -3 into here, think about it logically. I have it over here. How much is -3 plus 4? Well, that's going to make a 1. Is that right? So we're going to have a solid number inside of this parentheses. And so for the calculator, all that you need to do is input the expression only. Input it only once, and then it's going to do the work for you. You don't need to stress over it. First, we want to go ahead and open up a parenthesis. So the parentheses would be over here. Okay? And so now we're going to go ahead and use the change of base formula, log, and I'm going to start with my -3. And then it's going to be plus 4. We're going to close the parentheses, but remember, we're using the change of base formula. So that means that I'm going to have to divide by a log of 3. And then I'm going to close my parentheses. Okay, and then I'm going to have to close another parentheses. This parentheses closes that parentheses. Memorize the format. Is going to help you tremendously on your test, okay? And then the last thing is to -5. All right, so what we're doing is we are inputting a -3. If we have done this correctly, you guys, my prediction is going to be that it's going to give us a -5. Let's see if that is true. Hey, look at that. It is -5. And again, the work has already been done for you. All that you need to do now is recall back the expression, and you need to find a way how to do it on your calculator. For mine, I just press second and enter, and I'm able to recall back my expression, and then I can just press my up arrow, and then just continue switching the numbers. And so I'm going to go ahead and switch it to a -2. And so that's going to make -3.7874. Okay, always go 3 decimal places and round to the second decimal place. So again, look, stress-free. I'm just cruising now. I'm going to go to x being equal to -2, but now I'm going to replace it with a -1. And I'm going to press enter. So that's going to make a -3. Now, if my x is 0, my y is going to be, let's see. So I'm going to, and keep in mind that, you know, -0 and +0, they both mean the same thing. So here we go, -2.48. And then let's input 1. And so we get -2.07. All right, so I want to say that this pretty much covers it all, right? Identify the asymptotes. Okay, so let's go ahead and do that. The asymptote is going to be at x being equal to -4. We need to come up with the x-intercept. For the x-intercept, you know what? I'm going to have you tell me what the x-intercept is going to be. And the way that you are going to come up with it is you are going to continue plugging in values, and you know, eventually you're going to get to it, right? But let's say that that you're unable to figure it out using your calculator. I'm going to go ahead and give you guys a little something else. And it looks like this. We're going to solve for the value of x, okay? And so what I'm going to do is, and again, I apologize for this video being so long, but let's go ahead and do the following. Okay, so I'm going to go ahead and take my y is equal to 2 log of 3x plus 4, and then -5. All right, so what I'm going to do is I am going to solve for my value of x. To solve for the value of x, I need to set y equal to 0. And then I need to follow, you know, the properties of algebra, right? Addition, subtraction, multiplication, and division. So I need to get rid of this 5 first. So I'm going to introduce the addition property of equality. So 5 is equal to 2 log 3 x plus 4. All right, subtracted 5, added 5 on both sides. I need to get rid of this leading coefficient of 2. So I'm going to divide both sides by 2. So now I have 5 over 2 is equal to log 3x plus 4. And what I'm going to do next is I need to get rid of this little 3 over here. The only element that can get rid of a log of 3 is a base of 3. All right, so then we're going to have 3 to the 5 over 2 is equal, and then these two cancel each other out, and so we're going to be left with x plus 4. And then what I'm going to do is I'm going to minus 4 on each side. So 3 to the 5 over 2 minus 4 is equal to x. Okay, and then before you start panicking and saying, hey, I have never seen something like this before, hey, you know what? You have your calculator, it can help you. So all that you need to do is, go ahead and start from here. So 3 to the power of 5 divided by 2, all right? And then you're gonna minus 4. And there you have it, 11 point, what is it? 11.59 would be your x-intercept. Let's see, you know, let's go ahead and use this x. Let's use, let's use this x value and plug it into our original equation. Let's see what happens. So 2 times log, and then I'm gonna do all of these numbers. And then I'm gonna divide it by the log of 3, close parentheses, and then it's gonna be, oh, I actually forgot to do something, you guys. You know what, I'm gonna go ahead and start from here again, sorry. The reason I lost my concentration is because I started thinking about a sandwich, and yeah. And then keep in mind that we need to add 4 to it, right? And then we need to divide by a log of 3, close parentheses, this second parenthesis closes that initial parentheses there. And what it's saying is that whatever this is going to be multiplied by 2. And then we need to subtract 5 from it. If we've done this correctly, we should end up with something that is very, very close to 0. Okay, and that's what this is telling you. Imagine moving this decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's just a little something extra I wanted to show you guys. Anyhow, that's where the x-intercept lies. Okay, so with that being said, let's go ahead and I think I addressed everything. Asymptote, x-intercept, transformation, oh, the domain and range. Okay, so the range, let's start with that one first. Range is up and down, so the range is going to go from negative infinity to positive infinity. The domain is going to be from where, from -4 all the way up to positive infinity, right? The domain from 4 all the way up to positive infinity. Now, I'm using a parenthesis, so that means that the -4 is not included. If we wanted to write this in inequality format, it would look something like this. Where y is greater than -4. There you have it. All right. So that's going to complete this one problem. Okay, so the second problem on graphing logs is going to be, it goes on to say to write a log function of the form this that represents the following transformation. Okay, so let's go ahead and start with this. It says shift 5 units to the left. So shifting 5 units to the left, keep in mind that we are undoing the zero product property. So this says that x is equal to negative 5. And so we need to add 5 onto both sides. So we're going to end up with x plus 5 inside of the parentheses. Okay, and then it goes on to say reflected over the x-axis. So that means that it requires a negative. Vertically stretched by a factor of 4. Shifted 2 units down. And that's pretty much it. And so we're going to call it y is equal, and there you have it. Okay, and so there's some components that we need to figure out now. So the value of a is going to be negative 4. Okay, so for the value of h, you need to solve for x, right? And so it's going to be negative 5. And for k, it's going to be negative 2. And the vertical asymptote. That's a great question. Where is the vertical asymptote? So once again, get used to always graphing the parent graph first. Okay, parent graph is going to look like this. So the very first thing that we want to move is the vertical asymptote. And according to what we have over here, it's going to be moved 5 units to the left. 1, 2, 3, 4, 5. And so now we're able to see it better. And, you know, for this one, it's not asking us to graph it, but, you know, I always like to move the parent graph. And so I know that my vertical asymptote is going to be where x is equal to negative 5. And there you have it. Review this video, understand how to input a log function into your calculator. And I'm telling you, when it comes to your tests, it's going to be a lot easier. All right, so that's all the time that I have for this video. I'm gonna go eat my sandwich now. You study. All right, see you guys in the next video.